So our range is our up and down value. So the absolute highest value that I see coming out of this is 9. So our range is going to be 9, and it does have a closed circle. And the absolute lowest I see is -7, and it is also a closed circle, so it's there. Next thing I need to make sure of is there's no break in the data. So as you see, if you go from here to here, there is no spot where there isn't a value, so that would be our range. Remember, range is up and down. Domain is left and right. Well, this is also the edge of the domain, so the absolute lowest amount I see is -6, including -6, and then the absolute right value I see would be the 8, but remember, the 8 is not included, so I have to use parentheses. Oh. All right, intervals where the graph is positive. Remember, there's a difference between increasing, decreasing, and positive. So here's our line. Above it is positive, below it is negative. So it says intervals in which it is positive. Well, it's actually got a break because it goes negative for a minute there, but it is positive from the value -6, and it stays positive up until the value 3. But remember, not including 3, because at 3, it's equal to 0, and 0 is not positive. Does it ever go positive again? Yes, it does, right? It goes positive again at 5, and it stays positive until 8. Bracket or parentheses? I'm basically asking you, closed circle or open circle? Open circle is parentheses. And then we do this union sign, just like that. Now, to the one you were asking about. The average rate of change from -2 to 4. Well, -2 is right here. It has the ordered pair -2, 1. And then we go to 4. 4 has the ordered pair 4, -1. So when you're asked to find the rate of change, find 2 points, where it starts, where it ends. This is x1, this is y1, this is x2, this is y2. And then we use our slope formula. y2 minus y1 over x2 minus, I'm going to leave it as minus, actually. I don't want to confuse anybody. I was doing the math in my head, but it would actually be minus a negative, which does become positive. So my top is -2. My bottom, is +6. So the average rate of change is 1/3. I'm about to make a real big mess of this, but if you were to create a line, does that make sense for it to go down 1 over 1, 2, 3? Yes, it does. So that is our rate of change, -1/3. All right, what other number do we want to look at? So we're going to first write our arithmetic sequence. Remember, the formula for that is up here at the front, and the formula is a sub n. That means whatever term in the sequence is equal to a sub 1, the starting amount, plus the common difference, how much it changes, n minus 1. Well, this is kind of a different one. We know the starting amount, it's 3. We can see that it's changing by a factor of 8, don't we? We are used to getting the number, right? Find the 24th term, times the 68th term. Well, this one, it says, which answer is the 251st? So we're going to replace this with 251. This one, we're given the output. We're not asked to find the output. So it looks like this. So at this point, we have to solve for n. I want you to think before you start doing stuff this year, because distribution will happen, but a lot of times we can avoid distribution. So we subtract this away, it's 248. And instead of distributing an 8 and then ending up having to divide by 8 again, let's try this. Does 8 go into 248 evenly? I believe it does, right? 31 times. So instead of distributing the 8 and then having to divide it back out later, this is that. Then we have to add 1 to get n by itself. So it looks to me like 251 would be the 32nd term in the sequence. It's very easy to check your answer on this, by the way. Go back to this equation and plug in 32 and see if it equals 251. It says, describe the transformation of the parent function absolute value of x. Well, think about this first of all. We'll do all the values at the end. Remember, if it happens outside of the grouping symbol, it's a vertical. If it's adding or subtracting, it's a shift. So these are all vertical shifts. So this one is going down 6. This one is also going down 6. This one is going up 6. And then this one is going up 6. I feel like we're all really good at those. I'm not really concerned about those. Okay? Now, remember these as well. We will not see this tomorrow. I will tell you what that is real quick, but that negative sign in the horizontal, that's a horizontal flip. But we will not have those tomorrow. So what does the +4 do? Y left, it's a plus sign. The inverse, let's use the word inverse, right? Yep. So what's letter B doing? Also left. And again, we're ignoring these because that does change things. This one is going to go right. And so is this one. When in doubt, graph. All right? When not in doubt, graph. All right? Why not? What's the graph going to hurt you? It's either going to point out that you're right or it's going to point out that you're wrong. Either of those things are good things. Okay? Trust your graph. Trust your calculator on these things. Oh, thank you. The negative sign in front is a vertical reflection. That's a vertical reflection, isn't it? Or it could be stated as reflection across X. No, she's right. She is right. It would be left. And a reflection across the x-axis. So Nevaeh's ready for the test tomorrow. It's good recognition. Now, I'll say this. Had I graphed those, it would have looked nothing like what I just described, wouldn't it have? And it would have pointed out. So please graph tomorrow. Filling a bucket of 4.5 liters at a rate of half a liter per minute. What is the domain? Remember, that's the input values on these. That's our x's. As a function, as it represents the volume of water in a bucket after x minutes. Okay, well, let's talk about the basics of this. So x is minutes, not the liters. All right, so it's the amount of time. So what's the least amount of time Rufus could fill. He can't fill negative time. So it's got to be 0, but that really doesn't help us because all of our answers are 0, right? So let's talk about what is the maximum amount of time that Rufus will fill. He's got a 4.5 liter bucket, half a liter per minute. What's the maximum amount of time he's going to spend? Okay. How long does it take him to fill a liter? How many minutes? 2 minutes to fill a full liter, right? So 2 minutes equals 1 liter. He's got 4.5 liters. How many minutes is that going to take him? 9 minutes, right? 2 times 4.5 is 9 minutes. So his domain is going to be 0 to 9 minutes, because what happens after 9 minutes? He's not filling the bucket anymore, right? He's filling the area around the bucket because the bucket's already full. Now, what would our range be, just for argument's sake? The range would be y, of course, but what would it be if we did liters? What's the least amount is y. What's the most amount of liters of water he could have? 4.5. And remember, range is done with a y, domain is done with an x. When we have this, we'll have our parentheses, x. Remember, the way we shift something down is to go to the outside and subtract 2. The way we shift something right, remember, it's always a reverse behavior. So our instinct is to say plus 6, but it's actually minus 6. So that's how we would do this one. Next one, we'll just do 2 if that's okay. The next one, it is right. Let's do a left one. Let's do C. Left 2 units. Well, left 2 units is the opposite, which is plus 2. And then up 6 units would be that. So remember, if it moves up 2 units, that is something that happens outside of the parentheses, so that would happen from a plus 2, right? Outside parentheses does exactly what it's supposed to. How do I move right 2? Well, remember, moving right is inside of the parentheses, but everything has an inverse behavior. So instead of adding 2, which we would think, we have to subtract 2. And then the last one went up 2 units. That's going to be a plus 2. And it went left 2 units. You would think negative, but remember, inside the parentheses, it acts the opposite. Another thing I got to say to you on this, folks, graph these things tomorrow. Graph a lot. Graph early, graph often. Look and see. It will highlight mistakes. It will confirm correct answers. But if you don't do it, you get neither. All right? Graph a lot. So it says write 2 sequences that are arithmetic and 2 that are not. An arithmetic sequence would just be any kind of adding pattern. So I'm going to start with 1. Here is an arithmetic sequence. 1, will you write? 1, now it writes them all. 1, comma, well, plus 3 would be 4, plus 3 would be 7, plus 3 would be 10. That would be the example of an arithmetic sequence. And any kind of adding pattern you see. Okay, here's another one. Let's do like 90, 80, 70, 60. Is that an adding or subtracting pattern? Subtracting, it has a common difference of negative 10. So that would be an example of another arithmetic that is trending downward. Non-arithmetic, 1, you could have just put any series of numbers, 2, 8, 12, 14. There's no arithmetic pattern, but let's do the one that people can get confused. 1, 2, 4, 8, 16, dot, 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 dot. Do y'all remember what we called that when we didn't deal with them much? That's called a geometric because it's a multiplication pattern, right? It's a multiplication pattern. So this is an example of not. And then if we went, I don't know, 500, 250, 125, dot, dot, dot. That's an example of another geometric because it's a division pattern, right? And no pattern at all could have been 1, 3, 2, 7, 5. There's no pattern here. So it's definitely not arithmetic. So what we haven't seen is this n-1 subscript. That's what's known as a recursive formula. And what a recursive formula means is you have to build off of the last one. We can't jump all the way to the 30th one on a recursive formula. We have to go one by one by one by one. So on this particular one, it says 17 is our starting amount. And what we're going to do is take the previous amount and subtract 4. So 17 minus 4 would take us to 13. And we immediately pick up on the next number. So it'd be 13 minus 4, which is 9. 9 minus 4, which is 5. 5 minus 4, which is 1. 1 minus 4, which is negative 3. 1, 2, 3, 4, 5 terms. That's what's known as a recursive formula. So we know this is our sign for formula. If you see the a sub n minus 1, that means build off of the previous. It's known as a recursive formula. I don't think we have that on the test, but you might see it on your ACT or something of that nature. We'll work with our transformations on these. First off, the reflection across the vertical axis. Remember, our absolute value looks like this, doesn't it? That's what the parent function looks like. My graph got off a little bit there. Try that again. That's what the parent function looks like. So if I get a vertical reflection, there we go. What's going to happen is it's now going to be the same shape but upside down. That is the result of our negative sign. So that's taken care of. Okay. My 4 sign, or excuse me, plus 4, is going to shift it 4 units to the what? Left. So I'm going to go 4 units to the left, and I'm going to go 2 units down. So that's what that graph would look like. But do you notice that this is an inequality? So remember, ask the question about the origin. Plug in the origin and see if you get a true statement. So I plug in 0 and 0, that's the origin. So let's take a look. 0 plus 4. 0 plus 4 is 4. Absolute value of 4 is 4. The negative sign was just tagging along. So here's the question. Is negative 6 less than or equal to 0? Yes. So everywhere that the origin is, let's do a different color, is shaded. So I'm going to shade, in this case, everywhere above my absolute value. Remember, you can check any point, but why not choose the origin, right? The origin's so much easier. I'm going to say this one, not in elimination form. We're going to first talk about, I might do both ways. This can go into the matrix as well. This goes into the matrix as 3, 4, and then sometimes they'll put a line here, but there's no line in your matrix. Don't try to make it happen. And then this would be 1, 3, 8. So even on the ones that are not 3 by 3, you can still use the matrix to solve. Okay. Everybody look, because we didn't touch on this, but I think you all are all fine because I just did it for one. This says to write into matrix form. It doesn't even say solve. So the way we write this in matrix, remember the 3, it is a -6. 5, -2. And then they'll put this as an equal sign. So if you see the graph that has that line going down the middle, that's all that it's indicating. But don't try to put that in your matrix when you're solving. So remember, when we're doing elimination, we can eliminate any letter that we choose. In this case, I feel like the Y is the easiest letter to eliminate because I only have to multiply the second one. If I could get this 2 to be equal to a -6, then they would be set to eliminate. And it would be equal to a -6 if I multiply times -3. So -3 times 5 is -15. -3 times -2, essentially, -2 is 2y. And -3 times 12 is -36. So if we're doing elimination, we make that change. I'm actually going to just go ahead and move the other one down so I'm not confusing anybody. So now we have the 6y set to eliminate, and they do. This becomes -12x, and then this becomes, what does that equal? -9. -9. This one was meant to be done with the matrix, and I see why now. So we now have -12x equal to -9. To get the x by itself, we simply divide by -12. And x equals 3/4. What we would do next is we would substitute, 3/4 into our answer. So 3/4 times x, I'm replacing it here, minus 2y equals 12. That is 15/4. I promise you we won't have any questions like this. So everybody see what I just changed there? 12 is 48/4. Y'all see that? Why would I do such a silly thing? What is 48 divided by 4? 48 divided by 4 is 12. So all I did here was changed 12 to another version of 12, so I'd have a common denominator. I just did it in my head. All right, you divide by -2. Guys, I even regret doing this one. I promise you, you won't have anything like this on your test. Divided by 2, so times the top, 66. Ends up being this. And remember, your ordered pairs are your solution. Yeah, this will not be happening tomorrow. If you do a substitution, they will be integers, not crazy stuff like that. And if you, this even said, so if we had one that looked like this, we went from 54 to 104. That means we went up 50. And we went up 50 from sequence 6 to sequence 11. So that's 50 in 5 steps. The common difference is 10, right? So all you have to do is take your a sub 6, which is at 54. You back up to a sub 5, 4, 3, 2, and 1. And you will be at the first term. So minus 10 would be here, minus 10 would be here, minus 10, minus 10, minus 10. So your formula, there's your first term, your formula would be this. All right, you guys will have something like that. It will be freehand. Show your work. Show your work, because I don't care if you bounce back and forth. I don't care if you create formulas. Show how you got to your answer, though. Show how you got to your answer. You're good.